All right, here's example 3 with phase shift. So we're going to find the phase shift. Y equals 12 over 17 pi squared. That is an absolutely ridiculous number. Times the cosine of pi x plus 4 and then plus 9. Okay, so why is such an absurd, crazy number? Because it doesn't matter, right? We talked about in example 2 and I think maybe example 1 a little bit. In general, we have this a sine omega x minus phi plus b, a cosine omega x minus phi plus b. For phase shift, a and b are completely irrelevant. Okay, so crazy goofy number here, completely totally irrelevant, does not matter at all. Plus 9, that's our b out here, totally does not matter at all. Even the fact that it's cosine doesn't matter at all. Okay? Just the fact that we have cosine or sine, right, that tells us that we can do this. And then here's a, here's b, it does not matter at all. They don't even have to be there really. Just we have to have a cosine or sine, doesn't matter which one, and some stuff going on in here, like this, and then that tells us that we can look for a phase shift. Okay, so now we just have to identify what's phi and what's omega. So what's different about this example is inside here, normally in general it's omega x minus phi, but what we have here is pi x plus 4. Okay, so normally where we have a minus sign in general, here we have a plus sign. So how does that change things? Well, what we can do, it's actually fairly simple, and you may have done similar things in your pre-calculus or college algebra days when you were dealing with transformations and things like that. So y equals 12 over 17 pi squared, ridiculous number, times the cosine of, so what we're going to do is say pi x minus negative 4, okay, plus 9. All right, why are we doing that? Well, plus is the same thing as minus negative, okay? Remember, plus, that's the same thing as minus negative. So when you subtract a negative, you're really just adding. So minus negative means plus. Now, why are we doing that? Well, because we want to get in this general form here, omega x minus phi. Okay, so now we can easily identify omega x minus phi. Okay, so then we see right away omega is just pi, right? Omega is pi, and then phi, okay, so it's omega, which is pi, x is just x, minus, there's a minus sign, and then phi is what's left over, which is negative 4, okay? So phi is negative 4. So be very careful about that. Okay, it is maybe kind of weird with the minus signs, but again, it's just horizontal shift. That's all a phase shift is, just a horizontal shift. So if you remember from your pre-calculus or college algebra days, you might be kind of used to this negative sign being kind of backwards from what you'd expect, okay? Being kind of goofy like that. So anyway, phi is negative 4 here, because remember, pi x plus 4, so since in general it's omega x minus phi, we just want to rewrite that as minus, with the minus in the middle. Okay, so that's going to be pi x minus negative 4, because minus negative 4 means plus 4. So the phase shift still the same, it's just phi over omega, which phi is negative 4 and omega is pi. So the phase shift is negative 4 over pi. That's an incredibly strange number, but it is what it is, because omega is pi and phi is just negative 4. So the phase shift is always phi over omega. So the answer really, it is that simple. Once you have these numbers, you just divide them, negative 4 over pi, and that is our answer for example 3. Okay, so again, the main point here was if you have a plus in the middle, you want to rewrite it so that you have minus negative to take care of that plus, okay, minus negative. So then the reason you want to do that is because you want to get this minus sign here, okay, this minus sign, actually we're dealing with cosine, but it doesn't matter. But this minus sign and this minus sign are really the same thing. So you have omega x, okay, pi x, minus phi, and phi in this case was negative 4. Okay, so again, that's example 3, and the answer was negative 4 over pi for the phase shift.